Good afternoon, everyone, and welcome to the second Prokon Know-How episode for 2024. My name is Jacobus Oberholster. I'm an AEC and Prokon technical consultant with Micrographics, and I will be taking you through today's short clip dealing with understanding member fixities within SUMO. So going to SUMO, I've already got my model built up here, and I've got three elements actually here that I want to talk about today. So if I click on this element, you'll see it's got a start fixity and an end fixity. And the start position is defined or determined by where your first click is when you place the member, and your end fixity is defined or determined by your last click. So if I click on beam, first click there is start, second click or last click is the end. Okay, so that's very important. How you will know this, or how you can also just check this again, by looking at your discretized view. More than not, the lower node number will denote the start and the higher number the end, but it's not always going to be the case. Okay, so it's a good idea, or it helps, but it's not always going to be the case. Okay, in some circumstances, if you are really struggling or battling with determining which one is which, just redraw your member. Okay, so this pin convention, what this tells you is that there is rotational freedom around or about the local X, Y, and Z axis. So these axes are local and have nothing to do with the global axes you can see in the corner here. Okay, so your Z axis is your longitudinal axis of your member, your X axis is your strong axis, and your Y axis is your weak axis. And the program do pick those up. So if you rotate this member 90 degrees, the moments will display differently in your results workspace. Okay, and that is something we can maybe look at in a future video. But so pinned, again, the XYZ pin means that there's rotational freedom about the X, Y, and Z axis. So basically, these elements, because they're pinned, completely pinned from start to end, they can actually rotate around the longitudinal axis. And so if you run an analysis now, that analysis will fail because the model is not properly restrained, and actually it's unstable, sorry. If I change this from pinned to torsion, you'll see now that it's got an XY pin. But because it's only XY pin, it means that it is fixed about the Z axis against rotation. Okay, so it's something to wrap our heads around. Don't think of two-dimensional problems. Think of a three-dimensional problem. So the pin denotes rotational freedom. Okay, so XY pin has rotational freedom about the X and Y axis, but it is rotationally restrained or fixed about the Z axis. Okay, so actually, you will very seldom use the pinned fixity. In general, you'll only use the pinned fixity for braces, but more than not, you'll make use of your fixed and torsion fixed fixities for elements. All right, so I hope that that makes sense. If anything is unclear, please pop it in the comments below. And if this helped you or just clarified an issue for you, please put a like and subscribe to our channel for some more content. Thank you very much for watching, and I'll see you in our next episode.